Good afternoon, everyone. My name is Beth Lander. I am the Managing Director of PACSCL, and I am delighted to welcome you to the first of what the Program and Member Engagement Committee hopes will be a series on the topic of AI in the archives, a topic which makes me really glad that I will be retiring in a year and a half. I don't know why. We have a wonderful set of presenters, and I will introduce them all before we begin. Once I am done with the introductions, the presentations will begin. They will go in order, uninterrupted by Q&A. We will have Q&A via the chat at the end of all of the presentations. And I'm sorry if you can hear my doorbell on my Zoom. Let me begin with our first presenter, who unfortunately can't be with us in person, but did record her presentation ahead of time. Briana Giasullo is the Cataloging and Digital Resources Librarian at the Academy of Natural Sciences of Drexel University. Briana will be presenting in a pre-recorded video work done at the Academy of Natural Sciences in using AI and crowdsourcing to transcribe archival field journals. Written by natural scientists while on collecting expeditions, field journals are an amazing source of data about the natural world. Briana will describe the process, challenges, and successes she experienced while leading this project and learning along the way. Next will be David Nelson, who is the Digital Scholarship Programmer at the American Philosophical Society. His presentation will discuss ongoing efforts in handwritten text recognition at the American Philosophical Society. David's talk will discuss the practical implementation of a locally hosted open source HTR infrastructure without access to high-performing computing resources using Kraken and eScriptorium. Joe Corall, the repository architect at Lehigh University, and Ilhan Citak, who is the archival and special collections librarian there, will be showcasing Lehigh Library's successful integration of OpenAI's Whisper audio transcription tool into the Lehigh Preserve institutional repository, automatically making all resources containing audio searchable and more easily accessible. The library technology team recently received a Lyrasis Catalyst Fund Award to develop an open source tool for automated handwritten text recognition of manuscript documents, which is currently in development. Special Collections has also been experimenting with creating a chatbot capable of answering basic institutional history questions grounded in reliable historical resources. And last but not least is Rob Jagiela, who is the Assistant Archivist at the Barnes Foundation. His presentation will focus on how and why AI tools have been incorporated into the Barnes Foundation's Dear Dr. Barnes Digitization and Access project, primarily through the Read Co-op's Transcribus platform. It will provide an overview of the Transcribus's platform's functions, capabilities, and limitations, as well as a look into the workflows that Rob has developed around the platform over the course of the last year and a half. The application of AI to other areas of the project, such as building public digital access points, will also be touched on. And now I will bring up Briana.
Hi, everyone. Thank you for watching this video, and thank you, Beth, for agreeing to have me submit this video. Unfortunately, I cannot be there live with all of you, but I'm still happy to share a little bit about this project that I've been working on. My name is Briana Giasullo. I'm the Cataloging and Digital Resources Librarian at the Academy of Natural Sciences of Drexel University. And about a year or so ago, we started a project with the goal of transcribing our field journals from our archives. So because my face looks very pale right now, I'm sitting outside and the sun is beaming straight into my face. I'm going to share my screen and I will show you how this project works. So in addition to all of the art, photographs, correspondence, etc., that we have in the archives, field journals are a big one. They're very important and very interesting because they are the notebooks that scientists take out into the field while they are doing their research, while they're collecting specimens. And they contain just a whole amazing amount of different types of information. And they're all kind of different and unique depending on the author. Sometimes the authors are very systematic and will just give you a list of specimens that they've collected. Other authors like to treat it more like a diary and will tell you about their day, tell you about what they're eating, where they're traveling, etc. So there's just all kinds of incredible rich data that you can get from these field journals. So we began sharing our field journals on the Biodiversity Heritage Library, or BHL. And BHL is a really amazing resource, but they are a free online platform that provides access to biodiversity literature. And the content is contributed by natural history museums and libraries from all over the world. And this is what it looks like when we have a field journal uploaded to BHL. And another really cool thing that BHL does is anything that goes into BHL automatically goes through an OCR process that gives you this text that you see on the right. So for typed text, like the one that we're seeing, it does a pretty good job. And now I can search the entire text of this book. But the problem that we experience with our field journals is that because they are handwritten, we do not get a good OCR situation. And we really want to make these journals as accessible as possible and really get at the amazing data that's held within them. So in order to make this happen, we wanted to use AI transcription to get from this to some nice typed text for our field journals. And we collaborated with Amazon mainly because we already have a collaboration with them where we had been using them for cloud storage for a very long time. And we had representatives at Amazon who were willing to walk us through this process. Getting into some of the technical stuff here, it's a Python script. Basically, what this script does is tells my Amazon Web Services that anytime I put an image, a JPEG specifically, into this bucket that they call it, the ANS upload bucket. S3 buckets are simple storage solution is what S3 stands for. But basically I get these two buckets here, the upload bucket, the process bucket. I put my JPEGs into the upload bucket, and then that triggers the script that I showed you earlier that says, okay, any image, any JPEG that goes into this bucket, shove it through Amazon Textract, and then output the text into a plain text file here in my process bucket. And we went with plain text files as the output just because they're very easy to download and manipulate them. Once we have them in plain text format, you can do a lot with them. And that is where the crowdsourcing comes in because, as I will show you, the text results are not perfect, but I'm going to navigate over to my crowdsourcing project. Here we go. So let me back up a little bit. This is Zooniverse, which is a free online crowdsourcing program. And many science organizations are using this nowadays to create online projects where anyone from the public can go to this website and can begin helping with science. So we just ask volunteers to correct the machine-generated transcriptions because, like I said, they have errors in them, and I'll show you an example of that. So here we have our image on the left, and this is the text that Amazon Textract came up with. And you can kind of do, maybe I'll zoom in a little bit here. You can compare, I think this word is supposed to be upwards, so I'm gonna change that. Upwards of 200 crystals. I think that should be mostly. It looks like they put mostly under 1 carat, I'm guessing. Change that. But this is it, essentially. This is the project. If you go to our Zooniverse website, which I will provide the link to that at the end of this presentation, as well as my contact information, this is what you can do. And when you are all set, you would go down to the bottom here and say, okay, corrections made, and then you would hit done. I'm not going to hit done here, though, because I don't want my bad corrections to be submitted, because when you submit them, they go into our set of data. And I can then, as the project builder, I can export that data. So eventually you get a transcript that's kind of a blend of hopefully the most accurate transcript, but that's never a guarantee. So we still get mistakes. But I will show you what it looks like when it's finished. So this is what it looks like when we have the field journal completely transcribed and available in BHL. We do add a little disclaimer just to be transparent about the use of AI and to alert people that this transcription will contain errors. So the text really opens up a lot of possibilities now that I can search through here. There was one day that I thought was particularly funny. After a frightfully rough trip, we arrived in Havana 3 hours late, too well shaken up to go collecting. So that wasn't a great day, but it's cool that you get these little snippets of what they were going through throughout their day, as well as the interesting data. Down here, we now see that some species names are showing up. I clicked on the species name, and this now shows me every item in BHL, assuming it has been properly OCR'd, that has mention of that species. So I can click and be taken directly to the page where that species is mentioned. So this can really help with research and just really makes access to these journals so much better. Just out of curiosity, I copied and pasted a bunch of the text from the journal and threw it into ChatGPT. I wanted to get the text from the unstructured string of text with no structure whatsoever. I wanted to see if I could get that into structured data with headings like species, locations, names, subjects, and other data points. And ChatGPT came up with a response that looked like this, and then I output it into a spreadsheet. And so here's our spreadsheet. And it's kind of cool. I mean, of course, we would need to verify this information. As I said, the transcripts are not perfect, and we all know that AI makes mistakes. Sometimes it hallucinates, sometimes it gives us false information, but this is a cool start, I think. This is a good start. We have dates, we have locations. This is really cool. We're seeing some species names here. We're seeing both the scientific names and the common names. We got some other animals. We got a snake, scorpion, some fish. I do remember a page involving a list of fish. But I was really interested because there's only two names here. And the one I saw Mrs. Slauson, and I was like, oh, that's interesting. You know, we don't see women's names shown too often in the natural sciences and in our field journals. You know, it was kind of like a guy's game back in the day. I searched in our archival database. We have an archive space database for finding needs. And I found Slauson, Annie Trumbell Slauson. And it looks like she has ties to the American Entomological Society. And I searched that name, and sure enough, we have a Wikipedia page. There is a section here that says Slauson collected an extensive number of insect specimens in Florida, especially near Miami. And sure enough, if we go back to our spreadsheet here with Mrs. Slauson, we go to our location, we see that Hubbard was in Miami, Florida that day. So I can go back to our field journal and I can search for Slauson. Oh, here I already did it, but it's cool that I can now be brought directly to the page where her name is mentioned right here. So imagine what we can do if we continue this work and get more data and then maybe have students or volunteers who want to like verify some of the information that we see in these spreadsheets here. It's just really cool building these connections and seeing where these field journals can take us, what they can teach us about the natural world, but also about the authors and maybe other people who are mentioned in them that we were not aware of before. It just opens up a lot of possibilities that I'm very excited about. So that concludes my talk. If you have any other questions, if you want to help on our Zooniverse project, the link is here, the tiny URL that we created. So you can go there. You can edit some field journal transcripts if you want. Have at it. So thank you everyone again. And maybe next time I'll be live with all of you.
I'm going to drop my presentation in the chat so that you can follow along. And because I hope that I can get to everything, and I will share the presentation here so we can see it. Great. Okay, wait, no, that's the wrong button. Okay, so I'm going to be talking about our use of eScriptorium and Kraken to begin transcribing documents at the American Philosophical Society. So the background for this is that I basically had the idea that it would be really fun to do HTR. Most of our collections are manuscript holdings. And as we know, if we don't transcribe these documents, they're not accessible for full text search. So our needs at the APS for HTR had to fit within more or less these following constraints. We want something that was open source. This is an institutional commitment. We generally don't use cloud storage or web services, so we wanted something that could be run locally on our own machines. My background is in digital humanities, not in archives and libraries. So for me, that was the community that I was sort of cued into and the one that I was more interested in working with. And also, our needs are for something that's multilingual. We don't have a lot of materials that are not in Latin script, so we didn't need something necessarily that could handle Chinese or Arabic as much. We just don't have those collections as much, but we do have a lot of collections in different languages. We have a lot of collections in indigenous languages as well. So we wanted to make sure that we picked something that wasn't going to tie us to being English only. Our pilot project for this is the Revolutionary City, which is a multi-archive digital project that attempts to gather all manuscript materials about Philadelphia and its role in the American Revolution. So we have materials from APS, from Historical Society of Pennsylvania, Library Company, Penn, City Archives. I'm not going to name all the partners, but we have many partners. If you have materials and you'd like to join, please email us. Um, so this is our pilot project and some information about the corpus that we were working with. So as I said, multi-institutional. Most of the materials are in English. Most of them are handwritten. We've excluded most print, but not all. But we do have some French and we have some German. Um, and the German is, of course, in Kurrentschrift, so not in the same type of script. And then we also have a little bit of Yiddish. I don't know if we're ever going to get the German and the Yiddish transcribed, but it's sky is the limit. We have like over 50,000 manuscript pages, more added day to day, and a lot of variety in the structures and things. So we need something that was fairly robust. Our initial goal was to transcribe just the English and the French. We maybe will do the German and the Yiddish later, but we don't have a Yiddish speaker, so we can't check it anyway. And then we want to be able to handle basically just correspondence and journals, but we are not trying to do receipts or ledgers or anything very bizarre at this point. And then we also want to integrate HTR into basically every aspect of this program. So all of our interns, we wanted to have them transcribe using this. We wanted to have public events where we had people transcribe doing this. And on Thursday, we're having a transcribathon if you are interested in trying this out for yourself, where we will be using eScriptorium. So I'm not going to talk too much about HTR, but I just want to if you're not familiar with HTR, it's a multi-step process. So first we have to figure out where the text is on the page, and then only after we've figured out where the text is on the page, then can we actually decode the text. And so one of the things about using Kraken and eScriptorium is that it takes these two steps as different and distinct steps, and they have to be handled separately. And that's one of the maybe disadvantages of using Kraken and eScriptorium, but it's also one of its advantages because you don't just get like a SAC-suit solution. You can train models both for detecting where text is on the page and also for recognition. So for us, when we're thinking about like right now, we just are working with correspondence and journals, but in the future, when we want to work with receipts, ledgers, things like that, we'll need to train different models to detect where the text is on the page, because those things are not going to be normative in that way. So yeah, this is mostly here for a reference. So what is Kraken and eScriptorium? Kraken is an open source end-to-end automatic text recognition engine written in Python by Ben Kiesling, who's in Paris. It has a lot of users in Europe. There's pilots at Penn and Princeton locally and here at APS, of course. I think of it as the primary open source competitor to Transcribus. You can train your own models. Um, it doesn't come with any default models, so you can't use it out of the box. You have to train your own models to do anything with it. But there's a very active community that's sharing a lot of models. So like if you know like we haven't worked on training a German model because I know there's a German model out there already that's going to work quite well. So that's very nice. Because it was developed by digital humanists, it's very, very responsive to transcription conventions. And this is actually both a blessing and a curse. It means that like when we have volunteers transcribe, a lot of the noise that ends up in their transcription data ends up in the model, and that actually creates a lot of problems for us. So it's good because we get very high quality transcriptions that are diplomatic transcriptions that look like, you know, how I would want them to look. But any mistake in that transcription is amplified in the training data. It also was designed primarily to work with non-Latin text. So although we're using it mostly for English, we know in the future if we have to handle another language or text, we will be able to. These are the problems. There are several problems. It's not a hosted software, so you have to download it yourself and install it yourself. And that was not the easiest process. I can talk a little bit about what that entails in the Q&A if you're curious. And you do need some specialized hardware. So we don't have a GPU institutionally here. We don't have a high-performing computing cluster. We don't have any of these larger infrastructure things that that you might think of when you're thinking of doing AI training. So what we did is you can do something like use Google Colab, AWS, and use a GPU there. But what we did is my husband is actually a very avid gamer, and he has a very powerful gaming computer. And so I was like, I wonder if I can train models on his computer. And the answer is yes, indeed, I could. So we made a one-time purchase of a fairly expensive desktop computer with a GPU that's like basically just a souped-up gaming computer. And we were able to train models on that. So you don't actually need necessarily, for a small user base, you don't need necessarily to have tons of resources. But it does mean that I have to export all of the data from eScriptorium, which is not the easiest thing in the world. And then I have to train it on my other computer. And then it's this whole process. I can talk a little bit about that. To integrate the transcriptions into our digital library, we have to have them in HOCR format, but eScriptorium does not provide an HOCR output. So that's another thing that we have to deal with. As I said, you have to you have to make your own training data or find somebody else's training data. There are resources for sharing training data out there, but you know, generally you're going to want to model it to your own corpus. So we used our internship program to generate training data. And after training, you know, whipping the interns a little bit into shape, they're actually very, very good at generating very high quality training data. And so we have been able to generate models using the internship program. Kraken really, I think, avoids a one-size-fits-all approach. It's very bespoke, which is powerful because it means it can fit your corpus very well. So, for instance, we had some journals from Historical Society of Pennsylvania that we had a huge run of them. And so we trained a model just on Sarah Logan Fisher's handwriting, and we got like 96, 98% accuracy. But again, it's a very bespoke purpose. So that's not going to necessarily work for all cases. And you're going to have to learn something about how HTR works and how training machine learning models works. So this is an example of what our results are looking like right now. We're getting about 93 to 96% accuracy on English text. I am at the point where I would be happy putting this in our digital library with no correction. I think this is good enough considering how OCR itself is not perfect. So I think we've really kind of achieved, you know, success. At first, we were very much worried about, you know, we need to correct everything, but now I think I'm more comfortable with just putting a disclaimer up there. So we can now upload transcriptions into our digital library, and they can be viewed this way. There's full text search for any document that has been transcribed for the RevCity project itself only. We're really making a lot of progress. Okay. So summarizing quickly, the next steps for us are to run automatic inference on everything in RevCity, but we need to come up with a process for this. We need a way to detect and get rid of really bad output. We're looking into post correction, which I can talk about in the Q&A. I'm running out of time. Again, we need to find a pipeline so that we can select the right model, run it, and upload it into the repository. We're looking into alternatives as well, but again, we're constrained by the institutional commitment to open source and uh, that type of limitation. And then the next step after that will be to apply HTR to the rest of our collections, which will be a daunting challenge because we'll have different handwritings in different centuries. But that is it for me. Thank you for listening. And yeah, I'll look forward to your questions.
Thank you, David. And now we will pass it off to Joe and Ilhan.
Okay, thank you. And I will share my screen. So, good afternoon, everyone. I'm Ilhan Citak, Archives and Special Collections Librarian at Lehigh University, and I'm filling in for our Digital Archives and Special Collections Librarian, Alex Jaffa, who became a father last week. He is on leave for a few days, and he sends his best wishes and says everyone is healthy and fine. Today, I'd like to share our recent development in the Lehigh Preserve that's transforming how we approach our archival work, specifically how we are using Islandora Whisper and AI-powered transcription tool to process our alumni oral history interviews. As many of you know, the Lehigh Preserve is our digital repository for preserving and sharing the university's scholarly and historical materials. Among these collections, our alumni oral histories are particularly valuable. They capture the voices, experiences, and memories of Lehigh graduates across generations. However, these rich audio recordings have always presented a challenge. They are time-consuming to process, difficult to search, and often inaccessible for researchers who prefer text or need it for accessibility reasons. That's where Islandora Whisper comes in. Whisper is an AI speech recognition model developed by OpenAI and integrated in our Islandora system. It listens to the recorded interviews and automatically generates accurate scripts in a fraction of time. It will take human transcriber for a long time, of course. But what's most exciting is not just the time is saved, it is how AI enhances archival accessibility and discovery. Once the transcripts are generated, they become searchable text within the Lehigh Preserve. That means researchers can search for specific names, topics, or events across the interviews and instantly locate every relevant mention. What used to require hours of listening and note-taking can now be done in seconds. This fundamentally changes how users interact with oral histories as a research source. In a broader sense, this project illustrates how artificial intelligence is reshaping archival practice. AI tools like Whispers now allow us to process large volumes of materials quickly, making backlogs manageable, expand accessibility for users, and improve discoverability by linking spoken word content with metadata and search systems. I like to mention two archival reference stories that Whisper made possible. Jennifer Waits, assistant curator at the Internet Archive's Digital Library of Amateur Radio and Communications and College Radio, contacted us for historical files on Lehigh College Radio. I gathered some information and set up a Zoom meeting with her in case she wanted to dig up more. While I was demonstrating a search in Lehigh Preserve for Lehigh Radio, we located two alumni oral histories. She was so impressed seeing this search function that highlighted the exact locations in the audio file as well as the transcribed text. She found these stories very useful, but mainly very impressed with the success of Whisper. Lisa Sparrow Serrano was the other person. She is a local NPR host and a podcast producer who wanted a few facts about our local factories that are gone now. Thanks to these automated transcriptions, I was able to locate 2 oral history interviews for her to add a personal flavor to the podcast story. As its core, archives are among connecting people with the past. By integrating AI strategically, we are enhancing archivists' ability to locate more relevant resources. AI becomes a partner that helps us unlock voices from our collections that might otherwise remain silent. So as we move forward with Alondora Whisper in the Lehigh Preserve, we are not just adapting a new technology, we are embracing a new way of doing archival work. We are ensuring that Lehigh's stories, spoken decades ago, can continue to speak clearly for future generations. Now, Joe Corall will talk about our current Lyrasis Catalyst grant. Thank you. And Joe.
All right, thank you, Ilhan. Share my screen. So wanted to give a quick update on a project that we currently have under development here at Lehigh. We're calling it HOCR Edit. It's a new tool we're creating for transcribing handwritten text. A little bit of background on the project. In fall of 2024, Lehigh's Special Collections and Library Technology departments, we collaborated to create a microservice for our Islandora repository to leverage generative AI to add handwritten text recognition capabilities to the repo. So the microservice would allow for automatically indexing full text of handwritten documents in the repository. And we wanted to sort of pull the thread on this. We felt like there was more to work on here, and we applied for a Lyrasis Catalyst grant, which we were awarded in June of this year. And the proposal sought to generalize this microservice and explore the next steps for automated transcription. Specifically, we wanted to be able to create HOCR output, which would allow for highlighting of search terms in our scanned images. So what we've done so far is we've started development on 2 tools. One tool is a command line utility that performs a quantitative analysis using an algorithm called Levenshtein distance. And it measures the output from an LLM against a North Star data set that we transcribe manually that we know is accurate. And the second tool we're making is a web-based service that facilitates more of a qualitative analysis that allows editing the HOCR output right in the web service. So I'm going to stop sharing here and go to the repos. They're linked here in the documents, which I'll share in the chat after this presentation. This is the evaluation tool. You can see we've integrated with a lot of different models, Gemini, Olama, OpenAI, and you're able to just pass in we have like 30 documents that are images matched up with their transcriptions. And when you run an evaluation, it creates sort of an output that gets saved here in the repo. You can see all of our runs here measure what the provider response was and like what the accuracy was. This one had a word similarity of 91%. Back also the web service itself. So this is the qualitative analysis that allows actually editing the HOCR output. This is a web service that you provide an image. It uses the same algorithm that we're using with the eval tool to generate the HOCR, and then you're able to make corrections right in the web browser. You're able to like create new lines if it missed a line. You're able to edit the text within and then save a new HOCR document. What we learned so far is ChatGPT in particular has seemed unreliable, and I might be calling that one out just because it start had the best results, and so we were using it more. So perhaps the other ones have the same fault, but some days it'll work really well. Other days it'll just say like, I'm sorry, I can't help. And we've even like tried doing some prompt engineering, saying like, yes, you can help. And sometimes that actually does work. If it says I can't, you say it can, then it does. But some days it doesn't. So it's pretty unreliable. But we have identified Mistral as a viable open weight model that can be run locally. That seems to be like not quite at the level of OpenAI, but very, very close. Um, and also the prompt that you're giving it and then cleaning up the response it gives has proven to play a significant role in this project. So the next steps, we want to do more of a qualitative analysis on the results that we've been getting. We've ran a lot of evaluations, a lot of models, and have gotten the quantitative, but we want to dig in further and see if there's a better cleanup algorithm that we can to increase our accuracy. We want to create better line detection for the web browser interface. And then we're going to start actually running new documents through this interface and have students make corrections and measure that those corrections with what the output was to get, further iterate on this approach. And we'd like to integrate with the evaluation tool with other projects that perhaps aren't like large language models. We've identified this one in particular, Logi, that we'd like to run it and then see what, like, basically get the quantitative output of that project and see if maybe that model might be worth pursuing rather than these sort of chatbot models. And then eventually in spring of next year, we plan to deploy this web service for public use. So that's it. Thank you.
Thanks to Ilhan and Joe for their presentation. And last but not least, we'll hear from Rob.
All right. Hey, everybody. I'm Rob Jagiela, the Assistant Archivist here at the Barnes Foundation. Today, I'm going to talk about how and why we ended up incorporating some AI tools into a large digitization grant that wrapped up last year, but the work of which continues. So for a little context, the Dear Dr. Barnes project was a 3-year IMLS grant that we received to digitize and make accessible the Albert C. Barnes correspondence, which is our largest and most frequently consulted collection. The correspondence runs from 1902 through Barnes's death in 1951, and it's got his correspondence with artists, dealers, educators, other collectors. And so obviously it's hugely important for us internally in conducting research on our collection, understanding our history and the provenance of items in our collection. But it's also important to art historians, curators at other institutions, researchers, folks like that, and beyond. So to greatly oversimplify a bunch of work, as I'm sure folks are familiar with, we got our collection scanned. We built out the infrastructure to store it all, which was our dams. And then we set to creating these access points for people to be able to find and use these materials. That is when I was hired and when I came into this project. And so after starting the work of building out those public access points, talking with our legal counsel, we began to incorporate accessibility considerations into the work as well. We quickly identified that one of the primary hurdles to accessibility was that ensuring assistive technology would be able to access the information contained in the materials, as well as making it accessible for folks with different levels of vision and different sorts of considerations like that. Here's just a couple pieces of documentation I created during that process. And so naturally, our first step was to go to OCR. So we tested out several different applications, and we ended up with Abby Fine Reader, which is a pretty common piece of software, and you can see that at work in this image here. And it works pretty well. It's got like a pretty decent level of accuracy, but a large portion of the over 100,000 pages of these image files contain not typewritten stuff, but handwritten stuff. Almost always the handwritten stuff is intermingled with the typewritten stuff. So you get 3 pages typed, a page handwritten, or you get a typed page that has handwritten notes. So if we just run things through OCR, as a couple of their presenters have noted, you would get an extremely fragmented picture of the collection. So this sent us down a new rabbit hole as we considered our options for getting the typed and the handwritten stuff transcribed at the same time. Some of these we have heard talked about already today. We considered a couple of these different options. We tested some out on our materials, but ultimately we landed with Transcribus, which is what I'll talk about today. I will preface this by saying we went through this selection process about 2 years ago now, and obviously with this type of technology, that's a lifetime. Transcribus has evolved, and I'm sure these other options have evolved as well. But Transcribus is where we ended up, and so that's what I can tell you about. From like a technical perspective, Transcribus allowed us to import our materials and selectively process individual pages rather than entire files at once, which was important with the intermingling of types of material. It allowed us to process files in multiple languages at once, which is important because we have pages that contain primarily English and French, but occasionally German as well. So it's important for the system to be able to tell if both of those languages are present on the same page, what's what. We also liked that it has a variety of tagging features. Variety of export options was very important for us, which I'll talk more about in a minute, as well as an ability to collaborate within the platform. From the get-go, Transcribus, out of the ones that we tested at the time, was by far the most user-focused, sort of out-of-the-box, user-friendly platform that we came across. It has the ability to train new models on new material, on your material, but they already had a robust library of ready-to-go models, and they handled our materials well in our testing. Since we couldn't expect any IT support with this project, it was important that everything worked out of the gate or with sort of minimal fiddling on our part. At least that would be within our capabilities as a 3-person department. But in addition for it being easy for us to use, it also had to be easy for others to use because, again, we know that given that we're such a small department, we wouldn't be able to devote the time to see this from beginning to end ourselves. So we knew that we would have to use interns and volunteers, but not knowing that what their technical abilities would be, we would have to feel confident that we could train them easily and quickly, and that they wouldn't encounter technical issues when they're working independently. That's sort of what led us to Transcribus in particular. I want to walk you through sort of our workflow, how we use it specifically. So obviously, you have to upload your materials into the platform. One nice thing about it being fully web-based is there's no installation. We don't have to get IT approval to install new stuff on our machines. And you can log in and access your materials and work on stuff from any machine wherever you are. After you've uploaded things, you see that it sort of sorts it out into individual, what they call collections. We have them sorted by years here, and then we can sort them as well by correspondent. From there, you can get started on processing and transcribing the materials. So we open each PDF and we select all the pages that contain handwritten material. There's definitely a lot of judgment calls in this part of the project. Is it worth processing a page that's all typed but has 1 or 2 handwritten notes? Do you care about signatures, repetitive materials like receipts, shipping slips, things like that? But once you've made those decisions, you select your pages and then you can process. Once you do that, you tell it to sort of recognize, as they say, the pages. And there are, as you can see here, the models that you can select from. The one that we have found the most effective is this Text Titan, which they call a supermodel. And that just means that it's trained on a very large corpus in multiple languages. So you select your model, you click start, and then you wait. If you have a paid subscription, they will bump your jobs further up the list, but everything is done on their servers in Switzerland, where they're based. And so usually I select quite a few things to process and then get to correcting. Once it's processed, you can see that you've got the image of the original document on the left, and you have your text to correct on the right. It parses text line by line, and it numbers the lines, which corresponds to the reading order for those assistive technologies. There's a lot of different tools here, including things to parse out tables and forms, to recognize the layout of different documents. But for us, the primary function is for us to go in, either confirm that the transcription is correct or make the corrections if they are needed. Once that text is corrected, we mark the page as complete, so that the folks that we're collaborating with, interns, volunteers, know that we're all sort of on the same page. And then once an entire file is complete, we take all of the handwritten pages within that file and export them. This is where our use case gets very specific, because our goal is to create sort of one-to-one digital facsimiles of the original material. We really want researchers and users to be able to sort of flip back and see a one-to-one duplication, so they can go line by line, word by word, and know what they're looking at. Once we export as a PDF, which gives us an invisible text layer, and then we move into Adobe and do some reformatting so that it's actually legible to the human eye. And this is sort of what the end goal looks like. From there, we take these pages with the original image and our facsimile, splice them back into our original PDFs, and upload them online at all of the user access points and into our DAMs, so that everybody is seeing, the finished product. This is our correspondence spotlights, where we have Barnes's correspondence with, again, different artists, dealers, and this is accessible to the public. Our goal is to have everything that we publish on here transcribed with those facsimiles. As you can see, it is still a very labor-intensive and time-consuming process. I definitely had to shift my thinking from this will solve our transcription problem to this will make it maybe 30 to 40% easier to tackle our transcription problem. Obviously, some of that is self-inflicted. We're making these very specific facsimiles, but it has certainly helped compared to how I was doing it before this. And feel free to reach out to me with questions. I'm happy to talk to you about how we use it or how it can be used. And I think we will take some questions now.
Thank you very much, Rob, and thank you to all of our presenters. And if you have any questions, you can place them in the chat and I will relay them. And we do keep open the possibility of a more intense conversation about certain technical things. And I wish I was a prepared presenter to ask intelligent questions about this, all the uses that you've seen here, but unfortunately, I'm not. I am fascinated at how people are using this technology, and I'm also trepidatious about the use of this technology. I liked what Rob said about the thought that this would make things extremely easier, and instead the realization is that it might make things 30 to 40% easier. to do. Gary Soretsky has a question. Do any of these transcriptions tools also translate into English from another language?
Transcribus does not. It translates things in a variety of scripts and languages, but it would be another step to get it translated, which is something that we are dealing with here because, again, we have a lot of stuff in French, and our solution so far is to find people who can speak French to translate it for us.
Yeah,
I
ditto
think
with go ahead. Ditto with Kraken and Scriptorium. They do not translate. Although some people have had, this is a little different from your question, but some people have had success with like Ottoman Turkish written in Arabic script and then getting that to be transcribed directly into Latin script. So it does have some capacity, but it can't do actual translation, just transliteration in some very restricted contexts.
I
And
think
with the
we
solution we're
tested.
building.
Yeah,
Oh,
go
sorry, go
ahead.
ahead, Ilhan. Sorry.
We tested. Mine is very naive actually, but we tested Google Lens with Cyrillic alphabet magazines, for example, just looking at what is this, what is the title, what language is that? Google Lens was able to transcribe that into Latin and also translating into English too. But I don't know what the capacity is, but where you can take it in academically. But it was a very quick reference that was very successful with our Rodale archives with Men's Health magazine has 20 different languages, for example.
Joe, did you have anything else to add?
I was just going to say that we do have plans for like a next step. We're thinking like once we are able to extract the text, then I think we would need a separate service that then would do the translation.
I have one more thing to add if I can, which is I know I didn't talk about Whisper, but I have used Whisper as well. And one thing that Whisper does with the audio transcription is it can translate it, although sometimes it hallucinates and it will translate. Like I had something that was in English, but it put out the text in Spanish. So sometimes it does that when you don't want it to, but it does have that capacity.
Margaret Graham asks, do the AI tools pull your data into existing LLMs?
One of the reasons that we went with Transcribus, I mentioned that they're based in Switzerland. They're owned by the Reed Co-op, which is a co-op you can buy into. It's made up of mostly European museums and universities, and they have their own servers. And so all of the data lives on their servers. They won't use it to train other models unless you give them the okay. And so that was one of our considerations. So I could say, at least for Transcribus, it doesn't expose it to other LLMs.
And it's the same story with Kraken and eScriptorium. They actually neither of these models have a language model. Kraken doesn't use a language model, so it's sort of a more primitive form of HTR, which was part of the reason why we chose it because of our indigenous collections. We want something that was language agnostic, and because you run the models locally, they're not connected to a LLM. Although most people in the community do upload their data, and of course, once you have uploaded your data to the web, then it's of course accessible to AI harvesters. So, but the actual models themselves are not connected to LLMs and not exposed to them.
Margaret says, super helpful. Thanks. I do have one question going back to a previous job where I used a lot of sources that had printed script, particularly German, which can be very ornate. Have any of you had success in not translating, but transcribing a printed script using one of these tools?
I haven't worked with print in several years. don't want to admit how long, but I know that the back in like 2000. Okay, I am admitting how long. Back in like 2018, I used Tesseract for OCR of German print, and back then it was actually pretty good. So I think that with these newer improvements, I haven't done it recently, but I think it has improved quite a bit. Because it was good already in 2018, good enough for me at least.
Does anyone else in the audience have any other questions? Well, if not, I will thank Rob and David and Joe and Ilhan and Briana for their time and their experience and their knowledge. And I thank all of you who came to this event. Please keep your eyes open to the PACSCL list for future events, not only about AI in the archives, but other things as well. The next event on the PACSCL calendar will not have anything to do with artificial intelligence. It will be the fall social and the second cookie bake-off. We will be featuring historic cookie recipes. Announcement will go out to the list soon. That will be December 4th at the Ratskeller at the German Society of Pennsylvania. So thank you all very, very much for your time.